Good afternoon everyone, or good morning to those of you joining us from the West Coast. Very warm welcome to everyone that's joined us today. My name is Angela Juhas and I will be your webinar moderator today. Today we have a very special presentation. We'll be covering an update of the Guide to Pavement Technology Part 4B, which of course covers asphalt. We do have two webinar presenters today and I will introduce them formally in a moment. However, John Rebecki, I'm sure many of you are familiar with that name as he has had considerable involvement with this particular guide. And we also have Dr. Laszlo Pater, who is one of our own arborarians here, and he's based in our Brisbane office, so he'll be joining us via correspondence. Hello to you, Laszlo, and we look forward to chatting to you in a moment.
Hello, Angela.
So that's myself there. If you ever have feedback or comments with respect to any of our webinars, ladies and gentlemen, please don't hesitate to contact me at any time. We're aiming for about 1 hour for our presentation today, and of course we do record this session as well as all our other sessions as well to make them available to anyone who'd like to listen to them again. So please don't worry about taking notes as we are recording everything. Ladies and gentlemen, we welcome discussion, feedback, comments, thoughts of any variety. Please don't be shy. If you've got questions for our presenters, please do type them into the questions box. I'll also alert you in your control panels to the chat section, which is something we don't have here on the screen at the moment, but it sits below the questions box. I'll periodically type some discussion questions in there, so if you want to have a look now and again and give us your thoughts, that would also be great. Now, I think you've heard well and truly enough from me, and I would like to introduce our webinar presenters. And first of all, we do have John Rebecki joining me here in the Melbourne studio. How are you going, John?
I'm going well, thank you.
Lovely to see you as always, and we look forward to hearing your section of the presentation. You'll be starting us off with a bit of background, is that right?
Yes, yes.
Fantastic. So tell us a little bit about this guide and a little bit about yourself and your involvement.
Well, firstly for myself, but it all started for me as a young civil engineer when I applied for a position with the Country Roads Board thinking I would go and build roads in the country, but they offered me a position in the asphalt division, which I accepted, and I haven't really looked back. I've done a few other things along the way, but basically I've become a recognised expert in all aspects of asphalt spray seal technology. I've been heavily involved in the national committees of Austroads and the Australian Asphalt Pavement Association, Standards Australia, and particularly involved in editing of various technical publications and author of a few as well.
Well, it seems like you've got quite a lot to offer, and I'm sure your name is one that most of our audience would well and truly be familiar with if they're working in this sector anyway. Before we give a bit of background, I'll say hello to Laszlo joining us from Brisbane. Hello, Laszlo.
Hello, Angela. How are you today?
I'm very good, thank you. And more about you, though. Can you tell us about your involvement and what you'll be bringing to our presentation today? Sure.
As you mentioned, I'm a principal engineer here in Brisbane and ARB, and I joined ARB in the Brisbane office more than 4 years ago. I've been running a couple of Austroads projects mainly related to asphalt in general, SMA, EME, and I have been working with John together on the update of the guide Part 4B in the last 2.5 years, and I can tell you it's been a very interesting journey.
Oh, interesting. Okay, well, we look forward to hearing more about that. John, would you like to start us off with a bit of an overview?
Yes, well, what I first want to do is provide a little bit of a background to the development of this particular guide, and then I'll just give a brief outline of the structure. But in particular, we want to discuss the asphalt mix design procedures in some sort of detail because that's where the most attention has gone in the development of this particular update, and I guess that's where the greatest interest probably lies. And then there's, as Angela's already said, there's time for a little bit of discussion either during the presentation or at the end. Now, it sort of starts way back here in when NASRA, as it was known then, before Austroads, produced the Principles and Practice of Bituminous Surfacing in 2 volumes, Volume 1 Sprayed Seal and Volume 2 Plant Mix Work. And then in 1984, that particular Volume 2 was updated, now changed to Asphalt Work, and I in fact was editor of that particular publication. And these guides only provided a very general background introduction to the topic of asphalt or sprayed seals. And most of the detail then was in the road agency specifications or various manuals and overseas publications, and in particular the Asphalt Institute manual series and especially the MS2, which was the guide to asphalt mix design. Then this is where the asphalt review really sort of commenced, and I want to sort of pay tribute to John Bethune. He was asphalt engineer at one time in the Vic Roads and other senior positions, but he was the technical director of APA from 1988 to 2002. And it was he in particular that gave impetus to the asphalt R&D program of APA, and with significant funding from the APA members, and he expanded that into bringing all the road agencies in, as well as ARRB, as a National Asphalt Research Coordination Group. And there was a lot of activity there by the road agencies. They all had, most of them, all the eastern states, South Australia, fairly significant research capability and laboratories. And that resulted in outputs such as the gyropack, the matter, the fatigue test, the wheel tracking test. And then it was another thought of John Bethune to bring it all together in one particular publication, and it ultimately appeared as Austroads Pavement Reference Group APRG Report number 18. The first edition in May 1997 with various updates, republished as an Austroads technical report, and then almost hidden away as Appendix A in the first edition of Austroads Part 4B. And the mixed design procedure in there was modelled a little bit along the lines of the Sharp Superpave procedure, but using the Australian developed gyropack, which is a lot cheaper than the Superpave compactors, and also referred to the performance tests that had been developed for mixed stiffness, fatigue and wheel tracking. And it was called a provisional guide for a good reason, because a lot of the procedures hadn't been fully validated for the design, and some would say they probably still hadn't been properly validated. And some of the criticisms were that the gyropack wasn't really robust enough for the proper compaction of samples to represent field conditions, and some criticism that the work results that were in this guide made it read a little bit too much like a specification. And I would remind people that the asphalt guides, such as Part 4B, do not replace the specific requirements of road agency specifications, or and they're only really intended to be guides to good practice. Now, in the same era, John Bethune, who always had good ideas and pushed things along, thought that it would be a good idea to have a comprehensive guide to asphalt. And the outcome of that was the 2002 Asphalt Guide, of which I was the editor, although it had started its life, I think, as an internal document in the RTA New South Wales, but they'd run out of money. APA put some money into it. They got Austroads to contribute, and we finally produced the Asphalt Guide, published in 2002. Now that brings us to 2005, when Austroads decided that they would produce a comprehensive guide to all aspects of road technology, one part of it which being pavement technology. And the original concept that each part was going to consist of a brief overview document, only about 20 or 30 pages, but with all the detail in what were going to be called commentaries or appendices. And Part 4B was the very first guide to be produced under that particular model. And so it was based to some extent on the previous Asphalt guide, the 2002 guide, but only a very brief overview and with the detail put into the appendices. And then someone thought it would be a good idea to incorporate the whole of APRG 18 into this guide, which made it rather unwieldy. By this stage it had become huge, so that when it was finally published it had in fact only two appendices, the mixed design procedures, which was a reprint of APRG 18, and the framework specifications for asphalt and for asphalt recycling. And all the rest of the detail was in technical reports. And these were the technical reports that were published in 2006 prior to the first Part 4B in 2007, and they were virtually just segments taken out of the 2002 Asphalt Guide. Now, with the update of Part 4B, all those technical reports are now fully incorporated back into either Part 4B or into other relevant parts of the Pavement Technology series. And the technical report, which was on the previous slide, which was the framework specification for asphalt and asphalt recycling, that has disappeared because no one really took terribly much notice of it anyway. So we now come to the restructure of Part 4B, published in 2014 but developed over a period of several years. And the principal aims there were to go back and revisit the structure, because Austroads very quickly realised that the model that was used for the first edition of Part 4B didn't really work, and no other parts of the Pavement Technology series actually followed that model. So we needed to go back and revisit the model, and also have a look again at the mixed design procedures, because over the intervening period there had been some sort of changes and developments, and in doing that, of course, to harmonise it with other parts of the Guide to Pavement Technology. So the project commenced in July 2011. It involved a complete restructure of the document, an updating of the formatting, the pictures, charts and the reference documents, and alignment with other parts of the Austroads Pavement Technology series, as well as considering any changes in the interim in Austroads test methods and Australian standards. And this was the working group that was established by Austroads Pavement Technology Task Force. There was Jason Jones from Queensland, Hugo Van Leeuwen from South Australia, Paul Morissette from New South Wales, Steve Halligan, Western Australia, and Warren Carter as an industry representative, Warren from Downer Infrastructure, and as we've already said, myself and Laszlo as the editors. Now, that's a little bit of the background. The structure of the guide is there. All those chapters are relatively self-explanatory, but I will just give a brief indication of what is in particular its particular part. The introduction is really just, as it says, it's an introduction, a little bit of a background to the nature of asphalt and the operating environment. Section 2, which is the asphalt applications and mix types, provides a description of each individual type of asphalt, what its main uses are, but it also refers to Part 3 of the Austroads Guide to Pavement Technology, which covers surfacings. Part 3 on materials talks about the major part of each material that goes into it, but it also refers to other parts of the Austroads guides, because there's separate guides to bituminous materials, to aggregates and to recycled materials, which are referenced in Section 3. Section 4 on asphalt mix design is probably the most significant change in this Part 4B, because it brings into the design procedures from APRG 18, but also integrates it with Marshall procedures and a more comprehensive overview of mixed design, and some changes to reflect what are considered to be current practice. The section on asphalt manufacture is really bringing back into account what was in the old asphalt guide, and types of asphalt mixing plants and mixing procedures. The asphalt paving part of it is relatively brief, because asphalt paving is now more completely covered in Part 8 of the technology series, which is pavement construction. And similarly with the quality section there really only refers to asphalt manufacturing procedures, as the quality requirements for paving are in Part 8. And the appendices are what is now left of the old APRG 18, because what APRG 18 had in it was separate sections describing each of the asphalt tests and a little bit of advice on their use. And so each of those are now being retained as independent appendices in Part 4B. So that pretty much covers the background, and I guess there's an opportunity now to see if Angela's got anything come forward.
Audience is a little bit shy so far, or maybe everything you've said perhaps makes really clear sense. We don't have any questions at the moment, but please do get them through, ladies and gentlemen, if anything pops to mind. You don't have to wait until the scheduled question breaks. I'm more than happy for you to send them through as they come to mind. But what I will mention again, for those of you that joined us a little bit late today, is that we are recording today's session, so no need to take notes. You'll be able to review the material once the webinar has concluded. Okay, over to Laszlo, I believe, for the next stage of the presentation. Thank you, Laszlo.
Thank you, Angela, and thank you, John. I would like to continue with a practical part, as we already heard from John. A number of previous documents are now incorporated into the updated guide with a major rewrite and restructure on Section 4 asphalt mix design. And as it is now in Part 4B, the design procedure is reduced from 3 levels, as it used to be in APRG 18, to just 2 levels. And level 1 refers to the determination of the volumetrics based on either the Marshall or the gyratory compaction. And level 2 covers performance tests, and the performance tests are optional. Moving to the next slide, I would like to cover level 1 testing, as the process of the asphalt mix design normally involves the selection of the asphalt type, of course the aggregate and the binder type, and we are dealing with the determination of the aggregate grading and the binder content. And in this process the engineering properties of the asphalt mix will be optimized. It's very important that we are referring to optimized properties with regard to asphalt. In the process, the designer should keep it in mind that our final goal is in the design process that we are predicting in service behavior and performance, and we based our predictions on laboratory testing. and therefore it is very important that we produce in the laboratory samples which are relevant to or which are close to in-service conditions, in this case in-service densities and air void content. It is also quite an important aspect of the design that we are considering the manufacturing and the paving standards already in the design process, and these are not separate items. Would like to mention that globally all the design procedures are developed around hot mix dense graded asphalt, and this procedure can be certainly applied to other mix types. However, the procedure certainly depends on the mix type and may require some modification, but we are going to come back to this item a little bit later. Once the selection of the asphalt type has been made, the asphalt, this mixed design procedure starts really with level 1 testing, which again the determination of the volumetric properties. That includes testing of the bulk density, maximum density, the air voids, the voids of the mineral aggregate, the voids filled with binder, and if required the binder film index. If we are following the Marshall compaction, which is an option now in part 4b, the determination of the stability and the flow and the calculation of the Marshall quotient may be also required. And I would like to mention that this is the only mechanical testing which is performed at level 1, but again only related to Marshall compaction. Moving to the next slide, that gives you a visual experience of where the volumetric properties such as the bulk density, the VME, the VFB, and the stability, the flow are visualized as a function of the binder content. The Marshall stability and the flow may also be included in this analysis. It's definitely included in part 4b, as these properties really form part of the optimization of the volumetric properties. But we need to keep in mind that these two properties are not particularly considered as a good performance indicator, and additional level 2 testing may be also undertaken on mixes designed using the Marshall method. But that also relates mainly to heavy-duty mixes. If we are conducting a very detailed design, we prepare specimens with a target binder content plus minus 2 other binder contents, which is a 5-point Marshall design. In a simplified process, which you can see on this slide, refers to a 3-point design where we are targeting a binder content plus minus 1% below and above this target. Of course, once we plotted these values against the binder content, we are doing an analysis and we are comparing the results with the relevant specification requirements. Part of level 1 design, if you are moving to the next slide, sorry, part of level 1 is very important that we prepare samples which are really relevant to in-service conditions. Since the achieved air void content has an enormous impact on the mix performance, it's quite important that the laboratory design process, in the laboratory design process, we compact the asphalt to a density that is representative of the in-service condition. That process or procedure involves the compaction, the conditioning, and the mixing, where the temperatures should be selected, of course, according to the mix type, and the binder type. These aspects are not covered directly in Part 4B, but they are covered in the relevant Australian standards, which is 2891.2.2, that's for the gyratory compaction, and 2891.5, that's for the Marshall compaction. Just a note, to my best knowledge, that later standard for the Marshall compaction hasn't been published, but please watch out for the Australian standard website, as I think it will be published very soon. The test methods for the compaction of the samples for either level 1, the volumetric, or level 2, the mechanical testing, that may include the gyratory compaction. We've got two equipments for that in Australia. One is the gyropack, the other one is the servopack. We've got the Marshall compaction, and we also have the slab compaction, while the slab compaction mainly is for preparing specimens for level 2 testing. It's important to note that while a number of road agencies adopted the use of the gyratory compaction for sample preparation, other agencies still continue to use the Marshall compaction due to its simplicity and the collected relevant experience over time. Moving to the next slide, that refers to level 2 testing. And we have heard from John all the background and history around the developments of the fundamental tests in the last decades in Australia. And level 2 of the mixed design, as it is now in Part 4B, offers optional performance testing. And the performance testing, as we see, as we consider them, they predict the in-service performance and also delivers some basic engineering properties such as the stiffness or modulus and the fatigue, which may be then used in the mechanistic pavement design. Broadly, the procedures for the mechanical testing can be divided into three groups. One is the fundamental, or commonly referred to as the performance-based testing. These deliver engineering properties, again, such as the stiffness and the fatigue, and that may be tested by using the repeated load indirect tensile test or the repeated flexural bending. The other group is the simulative or the performance-related test. These are mainly the wheel tracking test and the moisture sensitivity test. And the third group, it's really a bit outstanding. That's the Marshall test, and that also considered as a mechanical test, but it's not fundamental and it's not simulative. It's an empirical test method, and it is performed only at level 1. Okay, once the designer has been through level 1 and level 2 testing, there may be a requirement for some verification with regard to the plant manufactured asphalt, as the volumetric properties of the plant produced and the laboratory produced mix may be slightly different, and therefore it is generally considered as a good practice that the volumetric properties are verified on the asphalt mix sampled from straight production. And based on these results, the designer may make some other adjustments, minor adjustments to the grading and the binder content, and the final mix can be selected on that basis. So, the final mix is usually called as the job mix formula or the nominated mix in some agencies. The next slide would give you just a quick summary on the performance related and performance based tests, which is the resilient modulus, the deformation resistance, which is the wear tracking, the stripping potential, which is the moisture sensitivity, and the fatigue life using the repeated flexural bending test. These tests, again, are optional and may be specified in the relevant road agency specifications. The next slide is a quick summary and update about the flow chart as it is in part 4B. That I think it has a clear structure and it provides a clear procedure. I'm not going to spend time discussing the details here. I already discussed that in general what is included in level 1 and level 2. Rather, I would like to give you some more information on the next slide with regard to actual steps in the design procedure. So the table 4.2, 3 and 4 in the updated part 4B provides practical guidance on the asphalt mix design steps. These are really outlined in much bigger tables in the updated guide, and you will find on this slide that we are referring here to level 0, but we just said we only have 2 levels. We refer to level 0 as testing of the constituent materials, which is basically testing of the binder and the aggregates. And moving to the next slide brings us to level 1 testing. This is just a snapshot what you can find in part 4B, table 4.3 on this slide for level 1 and 4.4 for level 2. These tables provide some real practical suggestions on how to perform the design, and it also has references to the relevant Australian standards and the Austroads test methods they're relevant. Please note that in table 4.4 you will find the word optional quite frequently, and this wording is intentional. It's really up to the road agency to specify these requirements. And that basically summarizes the mix design in general, but additionally I would like to move to the discussion of the stone mastic asphalt SMA on the next slide. And as I already mentioned earlier, the asphalt mix design procedures are developed all around the hot mix dense graded asphalt, but the procedure can be applied to other mixes, and the volumetric characteristics are essential to every asphalt mix, but this is particularly true for SMA. SMA is quite sensitive. A small variation in the grading and or the binder content can lead to low in situ air voids, which leads to flushing and bleeding on the surface, or on the other hand, another failure mode, it's a high in situ air void content that leads to permeability and really poor in situ performance. So this is why it's very important that in the laboratory compaction we are targeting an air void content and density which replicate the volumetric properties in field. And the next slide, on the next slide, I would like to discuss briefly the history around the SMA compaction, as there was a national workshop in 2006 and the workshop identified 10 issues around SMA design, and 4 of these were considered as critical, and as a result there has been numerous Austroads projects set up to address these issues around SMA design. And these issues were then investigated in research programs, and the outcomes are now included into the updated guide. Okay, what are these considerations? Just briefly, the gyropack compactor is not really capable of achieving the same level of compaction as the servo pack, and that may lead to some unreliable results in the laboratory, especially when using a polymer modified binder and or some active filler. Another outcome is that the servo pack provides the most reliable compaction with good indication of in-field densities, and also the Marshall compaction at 50 blows provides reliable indication of field compaction. So both compaction method may be used or may be considered in the design. As part of the compaction, as we already mentioned, the temperatures are very important, and the temperatures should be selected on the same basis as for dense graded mixes, and as discussed, these are covered in the relevant Australian standards. The next slide is also related to SMA, that is the grading. And during the update of Part 4B, it was identified that the road agencies in Australia specify SMA according to their good experiences, local good experiences, and there was not possible to identify a single common grading envelope for SMA in Australia. As a result, in Part 4B, referring to good practice, only the grading control points are specified, and that is based on the European product standard for SMA. We need to remember SMA is originally developed in Germany, where they perform very well. So the grading control points are now in Part 4B. It is tabulated in the guide, and the grading envelopes specified by different agencies fall now within the control point, and on that basis a framework could be provided for SMA as a good practice. The next slide again refers to the framework. It's not specification, but it provides a framework with regard to the binder content, and the binder content guidelines are in line with the binder content in Australia. 67.5% for SMA 7 and 10, 67% for SMA 14, and the relevant road agency may specify a narrower range in the design. Just a closing comment on the optimization process. The aggregate packing theory is mentioned in the guide. There is no real procedure provided there, because this is really a work in progress. But that may provide a good tool for designing better performing SMA. So this concludes the section on asphalt mix design, and this is where I can hand over to John to discuss the other asphalt types and other technology options included now in the updated guide. Thank you.
Absolutely. But before we do that, Laszlo, we've received a few questions. You wouldn't mind answering them, would you?
No, that's fine, absolutely.
Okay, wonderful. Well, I'll start with a question from Ramiz. Ramiz is joining us from Auckland, New Zealand, by the way. His question is relating to when to choose gyro pack and servo pack. So can you talk a little bit more about that?
Yeah, that's a really tricky question. The Australian standard really relates to gyratory compaction, but based on good practice, the different states may utilize different equipment, and so there is no real guidance there. But with regard to SMA, there is a clear suggestion that if you use the gyro pack for design, you have to be very careful and cautious what the results mean to you.
Good answer. Thank you, Ramiz, for your question. I hope we've answered that for you. Another question here from Robert. Robert is joining us from Qatar, actually, so we've got a few internationals with us, which is great. Robert's question is, it's more general, do gyro designs and Marshall designs generally correlate with each other, or are they treated as totally separate methods for determining the level 1 properties?
There has been quite a big effort to correlate these two compaction methods, and I'm referring to, deliberately to compaction method and not design method. There has been there was an Austroads research program back in the 90s where the gyratory cycles were related to the Marshall blows, but that may work very well to a certain asphalt type, but I'm not sure that all the asphalt types were covered in that research, and as far as I know, the relevant road agencies do put in some effort into correlating gyratory numbers with Marshall blows, and that would bring a clear question, a clear answer to this question. But in part 4B, we are relating back to the research in the 1990s.
No worries. Another question here from Taryn. Taryn's asking, what was the rationale behind changing from 3 levels of testing to 2?
The rationale was that it wasn't really clear when the level 2 and level 3 testing should be performed, and the different road agencies anyway specified that in different ways. So bringing all these test methods on the performance related and performance-based testing gives a clearer guidance what can be selected, and it's really up to the road agency based on their risk analysis or main failure mode which property to specify. John may want to add some more to this, but I'm not sure.
John, opening the microphone to you. Anything to add?
Oh, no. It was really that, as Laszlo says, there was confusion between when you went from 2 to 3 because they were virtually the same thing. So level 2 and level 3 are just now rolled into one level which covers the performance testing. Level 1 is all about volumetrics. And if I might just sort of add a little bit of comment to the previous question about whether gyropack and Marshall designs are the same, and the simple answer is no, that they are not. You would use one or the other. You wouldn't attempt to correlate the two.
Well, thank you. Feel free to jump in any time. Another question here from Yun, which sort of relates to what we discussed a little bit earlier, but perhaps we can elaborate a little bit more on that. The question is, have the road agencies already determined the level of testing required for various roads? So can we discuss that a little bit further?
I'm not sure. Yeah.
Can I just sort of butt in there? That's fairly clearly defined in the road agency specifications, and they do have quite clear guidelines. Road agencies such as Vic Roads have a code of practice for the design of asphalt mixes. Other road authorities have similar requirements built into their specifications which clearly state what level of design is required for what particular level of service.
Laszlo, was there anything that you'd like to add to that?
No, I think John covered that very well. Thank you, John.
No worries. All right, well, thank you to those of you who asked questions. Ramiz, Robert, Taryn and Yun, please keep them coming. But for the moment, we might move to the next stage of our presentation, which is back to John. So over to you, John.
Yes, well, the next thing we were going to talk about is open graded asphalt mix design, because as Laszlo said at the start of his presentation, the design procedures are basically developed around dense graded mixes, but we do need some variations for other types of asphalt mixes. And when it comes to open graded, there's no universal rational design procedure for open graded asphalt. And basically it's the volumetrics, which are grading binder content and air voids, which are the primary design requirement. The level 2 tests that are applied to dense graded mixes generally are not applied to open graded asphalt. But there are 2 additional performance tests in the Austroads test series, which is a binder drain-off test, and the other one is asphalt particle loss. And they are both applicable to open graded and do give some indication as to how those mixes might perform either during the manufacture or the placing, or even some level of in service. And in the first edition of APRG 18, there was an attempt to build a rational design procedure around those particular tests, but it was never properly validated, and we've now dropped that out of the current update. If we now move on to another variation, which is warm mix asphalt. Warm mix asphalt is probably the largest single sort of revolutionary change in asphalt manufacture and placing that's occurred in the last decade or so. And various ways of doing it. It started off with the people who promoted additives blended into the binder to change the binder flow characteristics so they could be mixed and placed at lower temperatures. People came along with other additives that could be added direct into the asphalt mixer, and then people found that simply by using water to foam the asphalt, it changed the way in which the binder could coat the aggregates at lower temperatures and also improve the placing. And then there's also the proprietary process that involves a sequential aggregate coating and binder foam techniques, but it does require a sort of special mixing plant. So when it comes to design, then the actual end product should be exactly the same as any other product, whether it's manufactured using a warm mix technology or done at standard temperatures. And the difficult part is able to simulate the mixing procedures in the laboratory, and some of the processes require special laboratory mixing equipment, or if it all gets too hard, then merely taking the material from the production and doing the testing on production mixes is a more effective way of ensuring that what you're testing is representative of what's going to be placed. And the tricky part of it also is ensuring that you have your mixing and compaction temperatures must be appropriate to the relevant warm mix technology. So that was about all that I sort of want to say about warm mix, unless people are going to ask questions. And then finally, there are a whole lot of other minor variations to the way that asphalt is put together or produced, and that includes the use of reclaimed asphalt pavement, which is a very important feature as we try to conserve materials. Asphalt is probably one of the most recyclable products that's out there because it should never be discarded. It should always be reused. In fact, in the United States, they say something like 80% of asphalt is recycled back into new asphalt pavements. So there are some guidelines in Part 4B on the design of mixers using reclaimed asphalt pavement. There are a few guidelines there on polymer modified binders because they do change the handling characteristics, the workability of the asphalt mix, and so it requires some adjustment to temperatures and compaction procedures. There's a little bit of advice on the use of crumb rubber, and also not entirely neglecting the use of cold mix materials, which are used in maintenance patching materials and the like. A little bit of advice on cold recycled asphalt, which is to take the reclaimed asphalt pavement, mix it with some fresh foam bitumen binder or emulsion binder and putting it down as a base material. And also we haven't entirely discarded discussion on fine gap graded asphalt, which is another variation of asphalt suitable for lightly trafficked applications where you want a nice smooth finish and a very workable mix that can be compacted to make a good durable asphalt. So there's a little bit on each of those materials in the guide, and I guess if people want to ask questions we can answer them. So that finishes the formal part of the presentation, and we're open to any further discussion.
Absolutely. Well, we've certainly got a few more minutes before our allocated time frame ends. So if anyone does have any last minute questions, please do send them through and we'll discuss those later. Just before we do that though, I would like to take this opportunity to thank John for coming into the studio here in Melbourne and joining me to give this presentation, and for all of the work that he and Laszlo have put into the presentation, obviously prior to today. Thank you, Laszlo, again for joining me from Brisbane today. It's been lovely to have both of you, and I thank you for your time. And I hope, though this is the first webinar, I believe, that you've both presented, that it won't be the last. Quite an interesting topic here, and with the questions coming through, it looks like maybe a follow-up webinar could be in order. If anyone would be interested in participating in anything like that, please do give us some feedback. We've received a question here from Oliver, and I'll just read that out to the presenters now. So Oliver's question is concerning polymer modified asphalt mixers. Would you accept modification directly in the mixer? I mean, not using the PMB, but an asphalt modifier modifying asphalt mix and not binder. That was a bit of a tongue twister for me. I hope I got that out right.
Yeah, it's a bit difficult to know. There are various ways that asphalt can be modified in the mixer. There are some of the warm mix technologies that do use an additive directly in the mixture, like one of them is to add zeolite, which sort of causes a foaming action in the bitumen, which simulates the same thing as the water-based foaming. There are some polymers that can be also added to the mixer, and that's sometimes used for crumb rubber mixers, although personally I feel that pre-blending the crumb rubber into bitumen is more effective than adding it to the mixer. So I'm not quite sure what other things the questioner had in mind.
Oliver, if there's anything more you'd like to add to your question, or obviously participants here today are most welcome to contact us after the webinar if questions come to mind, or if we haven't quite addressed them properly. Everyone will be sent this information, but our presenters' email addresses are there on the screen in case anyone does have any follow-up questions. We do have another question here from David. David Sullivan is asking what percentage of RAP or RAP is allowed in a mix?
Yes, oh, that's a wonderful question, and it depends who you ask.
Okay, well, we'll start with you, John, and then we'll get Laszlo's opinion as well.
Most of the road agencies have fairly clearly defined ideas on how much RAP they will allow into the mix, and it does depend on the particular mix type and the application. Now, over the years, some of the road authorities have been very conservative in what they did allow. I guess Vic Roads was always one that was foremost in allowing relatively high proportions of RAP, up to 30% or even 40% in some instances. Other road agencies sort of stuck to a more conservative 15-20% level, but only for certain mix types. Some road agencies wouldn't allow it at all. But there's certainly been a move now in the road agencies to come around to much higher proportions of RAP in all mix types. 20% is now becoming fairly well accepted in base course mixes, and it does depend a little bit on the capability of the asphalt manufacturing plant, because you need to properly blend the material, proper heat transfer to the material without overheating or damaging the material. So what we've also seen in more recent years is the development of asphalt mixing plants specifically designed to handle quite high proportions of RAP. 40% is quite feasible, even up to 50%, provided that people prepare the RAP material appropriately with gradings and checking of binder content and binder condition. So it's almost very open to interpretation.
Laszlo, was there anything you wanted to add to that?
Yeah, I think it's quite a timely question. We've got an ongoing or a running Austroads project, project TT1817, which looks into higher REP applications. And as John mentioned, a few road agencies are quite comfortable with higher percentages, while the others are a bit conservative. So this program really looks into developing a rational design procedure incorporating a higher percentage of REP. If you are talking about higher, that looks into the 40, maybe 50%, and that the project as it travels now looks into the REP binder properties using the DSR equipment, so it's a cheap and quick test method. But we have to keep it in mind. We can develop test methods and procedures, but the core and the basis of using REP appropriately starts with proper stockpile management. So because of the timely overlap, of course, the outcome of this project couldn't be included into the updated part 4B, but maybe next time.
Fantastic. Look, we are very short of time, but I will ask one more question then. We'll squeeze that in before we close this webinar off for today. And this question is also from Ramiz. Ramiz is asking, can RAP be used for OGPA and SMA? John?
In theory, yes, but in practice, most grade agencies exclude it. It's too difficult to accurately control the gradings for open graded and stone mastic to allow the use of RAP.
Laszlo, was there anything you wanted to add to that?
No, that's absolutely correct, and these are the suggestions in part 4B. So.
Perfect. Well, on that fine note, I might close off our webinar for this afternoon and thank our presenters once again for all of their efforts in putting together today's content, and for all of you, ladies and gentlemen, who have taken some time out of your afternoon to sit and listen to us today. I hope you found it very informative, and of course, if you do have any more discussion questions, don't be shy. We can be contacted at any time. On that note, goodbye, and we hope you can join us again next time. Have a great day.